Welcome. So you've been learning how to find the derivative. Let's take a step backwards and learn about what the derivative tells us. The derivative in context. Right, so here on the left-hand side we have the graph of f of x. And we're going to find, so when we're talking about the derivative tells us slopes at different points of tangency. Let's write that in. Pen never likes to write right off the bat. So the derivative tells us the slope of f of x at various points of tangency. And what's a point of tangency? Any point on the function. Any point on the function at all, we can draw a tangent line through. Right? And so let's take a look at our graph here. Well, some tangent lines, it's easy to figure out the slope, like there, there, and there. Right? Those slopes are easy to figure out where our graph turns around. So where I drew the horizontal lines, f prime of x is equal to 0. Right? In other words, f prime of x equals 0. So that's occurring on our graph at x equals negative 4. X equals 1. And x equals 5. Right? On our f of x, it's where we have horizontal tangent lines. Right? That's where we're going to find that f prime of x equals 0. Let's find a few more. All right, so then you have to sort of estimate. So it looks like maybe I'm going up 2 to the right one. That looks like maybe it's a slope of 2. This one, it's not as steep. Maybe it's half as steep, right? Looks like maybe it's going up 2 and to the right 2. So that would be a slope of 1. And then let's draw it over here as well. All right, so that looks really close to the first slope I drew. It looks like it might be going up 2 and to the right 1. So that looks like it also might be a slope of 2. Let's draw the rest of them in. All right, so, well, that looks like it might be a slope of negative 1. It looks like it's going down 2 and to the right 2. This is a little steeper. All right, so that's probably a slope of negative 2. It looks like it might be going down 2 and to the right 1. And then, oops, that's missing my point of tangency altogether. All right, so that looks like it might be a slope of 3. That looks a little steeper. Looks like it might be going down 3 and to the right 1. I think we've got all of our slopes for those various points of tangency on our graph. All right, so we want to first look at where f prime of x is greater than 0. All right, so f prime of x is greater than 0 because remember, the derivative tells us the slope. That's going to be greater than 0 where the slopes are positive. So f of x has a positive slope. It's increasing. And that's occurring at x equals negative 7, x equals negative 6, and x equals 3. And where is x less than 0? Well, that's going to be, where is f of x f prime of x less than 0. Don't forget, I can't forget to say the prime. So we want to know where is f prime of x less than 0. So that's going to be where f of x has a negative slope. It's decreasing. And that's occurring where x at x equals negative 2, x equals negative 1, and 3, 4, 5, x equals 7. Right. So we can use that information to graph f prime of x, because all f prime of x is, the graph of f prime of x is just the slopes at various points of tangency. So let's answer a couple other questions before we get to drawing the graph. So changes from positive to negative. So f prime of x is going to change from positive to negative when f of x changes from increasing to decreasing, right? From a positive slope to a negative slope, right? And that occurs at two places. X equals negative 4 and x equals 5. Notice that where f of x changes from increasing to decreasing, and f prime of x changes from positive to negative, the graph is going to have relative maximum values. Changes from negative to positive. Right? So where f prime of x changes from negative to positive, f of x changes from decreasing to increasing. I hope you can figure out my little abbreviation there. From decreasing to increasing. And that's going to occur at x equals 1. Notice that where f of x changes from decreasing to increasing, and f prime of x changes from negative to positive, f of x has a relative minimum. And we can use that fact to help us graph later on. All right, we're going to do one last thing on this page. I'm going to make a bunch of short videos because it's hard to squeeze the videos in with the time I have. Right? So I'll make lots of little short videos that you can watch one problem after another. And so the last thing we're going to do on this page is to try and graph the derivative. All right? So remember, the graph of the derivative is just the graphs of the slopes. Right? And let's start off with the easiest points. The easiest points of all are at negative 4 and at 1 and at, let's see, 1, 2, 3, 4, 5, because the slopes there are 0, right? So if the slopes are 0 on f of x, on f prime of x, those should be x-intercepts. Right? So those points are x-intercepts for f prime of x. Right? So those are some easy ones to graph. Right? So, and if we're above the x-axis, we're increasing. If f prime of x is below the x-axis, the f of x is decreasing. Because remember, the graph of f prime of x is simply the graph of the slopes. Right? So first of all, our graph starts off with a slope of, it's increasing pretty well, and it starts off with a slope of 2. And so that's at negative 7. Right? So we have a slope of 2. Now I'm not always great at drawing these graphs. I don't know what happens between my head and my hand, but they don't always look great. But I'm going to try and make this look great for you guys. All right, so then our slope, we start decreasing, right? So our slope, we're not increasing quite as much, right? Because then we're kind of slowing down. We're slowing down for that x-intercept, right? We're slowing down where f of x has that relative maximum. Right? And then the slopes change from increasing to decreasing. So now we're going to be below the x-axis. All right, so 1, 2, 3, 4. So about 4 we have a slope or at 0, excuse me. At negative 2 we have a slope of about negative 1. Right? We're decreasing. And then we start decreasing a little faster, because at negative 1 we have a slope of about negative 2. But notice the slope, we don't have the points graphed, but notice the slope, it gets less and less steep as it gets to that x-intercept, right? And that x-intercept corresponds right here where the slope, let me put that in there. So where the slope is 0 for f of x, the value of the function is 0 for f prime of x. Right? So, and then after we get to that relative minimum, right? Then we start increasing again. And so now at x equals, what is it, 3, we have a slope of about 2. Right? So now our graph is increasing. My graph never looks that good when I draw these. That's because I'm trying to connect all the little increasings and decreasings. All right, so now our graph is increasing, but you know it's got to slow down a bit. Right? It's still increasing because we still have positive slope, but it's not increasing as much, right? Because it's going to turn around. Right? And after x equals 5, our slope is negative. Matter of fact, by x by 7, our slope is all the way at negative 3, so we're decreasing pretty rapidly. A couple other things. Notice this graph is quadratic. This graph is cubic. Remember, for the power rule, the exponent decreases by 1. And one last thing I want to point out, I don't know, maybe I put it in yellow. All right, so here, yeah, that looks good. All right, notice our slopes are 0. That corresponds right here where the graph of f prime of x has x-intercepts. So a horizontal tangent on f of x corresponds with an x-intercept on f prime of x. And just to make it clear, this is f. Oops, yeah, now it's in black, not yellow. This is the graph of f prime of x. All right? Here where our graph is increasing, so our graph is increasing, right? And it's increasing from negative infinity, negative infinity all the way to 1, 2, 3, 4, right? Our graph is increasing. Notice that we are above the x-axis. So actually make that clear. What's above the x-axis? F prime of x is above the x-axis, where f of x is increasing. And then here where f of x is decreasing, so I can squeeze it in there. So f of x is decreasing here and over here. Notice that f prime of x is below the x-axis, where f of x is decreasing. So we got a lot out of this very simple little exercise about f of x and f prime of x. So come back and to the next video and we'll see some more things about the derivative. Thanks for watching. Bye for now.